Hey, how are you today?
All right.
Feeling better these days?
Yeah.
That's good. Give her a minute or two here. I was supposed to go through that identities test with you.
Oh, that's an old one, isn't it?
Yeah, that was I don't know if it was the last one or the one before it. One before it, I think, right? I don't think I went through it, so I'll go through that. We'll just give her one more minute, see if anybody else joins up, and then we'll go from there. All right. So yeah, if you girls want to grab that identity test, I'll go through that with you right now. Okay. And then I'll just answer any questions that you had from. We should be done chapter 4, so I'll give you an assignment for the weekend tomorrow. If you want to do that. Okay. All right. So, Brandon, I'm going to go through that identity test. I failed to do that earlier, so if you want to grab it, you can look at it. All right. So it starts with that, I believe. Oh, here we go. Sorry, I was looking at a copy and it didn't match up to what I thought. Okay. So that was over sine 2x. Okay. So sine 2x we know is 2 sine x cos x. So if I'm doing this question, I want to get rid of that 1, that negative 1. So to do that, I'm going to use the one that, for the cos 2x, I'm going to use 1 minus 2 sine squared x. Subtract 1. And the reason I do that is to get rid of the 1's, because 1 subtract 1 is 0. So I'm left with 2 sine squared x with a negative over 2 sine x cos x. 2's cancel, sine cancels with that one, and I'm left with negative tan x, which was A in that question. All right. B. Cotan theta plus tan theta. So cotan is cos theta over sine theta plus sine theta over cos theta. Sine theta, cos theta on the bottom would be your common denominator. So that gives me cos squared plus sine squared theta, which is equal to 1 over sine theta cos theta. Okay. Again, I'm going to go through this fairly quickly. So if you have questions that you want me to slow down on, let me know. Okay, again, convert sine squared theta over cos squared theta times 1 over sine theta. Add 1 over sine theta. So I can cancel that with that. All right, so then I am left with a common denominator. So that would be, messing around with this, so that would be cos squared theta sine theta, like that. And I would need this to be sine squared theta and add cos squared theta again. So that's 1 over cos squared theta sine theta. And if I convert it, it would be secant squared theta times cosecant theta, which is D in that one. Okay. Number 4, cos minus sine. Well, that's the same as the cos of pi over 5 plus pi over 6. Okay, so cos, sine, and with a minus, it's the opposite sign, and it's the cos. So that's the cos of, what is that? 6 pi plus 5 pi all over 30. So the cos of 11 pi over 30. And then the last one on that first page, 4 cos squared x minus 2. If I factor out a 2, I get 2 cos squared x minus 1, like that. And then I end up with 2 cos 2x. So that's a case of factoring for that question. 6 was one that caused some problems, so let's have a look at it. So I've got sine theta is equal to c. It's in the first quadrant, and I want to know what cos pi plus theta is. All right, so first of all, cos pi cos theta minus sine pi sine theta. That's the identity. So I already have cos pi. The cos of pi is -1 times cos theta, right? Sine pi is 0. 0 times sine theta is still 0. So basically what I need to do is I need to find out what that is. -1 cos theta. So now I draw out my triangle. It says that sine theta is c. So that's c over 1. So to get this right here, that is x is equal to the square root of 1 minus c squared. All right. So my cos theta is x over 1. X is equal to this. So my solution is that. Square root of, go ahead.
Sorry, for that one I used sine squared plus cos squared is equal to 1. And then I substituted in my c and my theta plus 0 for my pi plus theta and for cos, and then I solved it like that. Is that still correct?
Did you get that answer though?
Yeah, I got the same answer.
Yeah. No, then that's 100% right. Yeah, that's all good. Yeah, no good. Okay, so now we get into, this is the meat and potatoes of this whole section, is can you find the cos of 105? Well, that's the cos of 60 degrees, sine 45 degrees. So what do we have? 1/2 root 2 over 2, subtract root 3 over 2, root 2 over 2, root 2 minus root 6 all over 4. There's the cos of 105 degrees. So the question is not tough. but we still struggle with it. We need to be able to, like, if it came down to the exam, again, this is 100% on the non-calculator section of the exam. You have to do this. And generally they would put like secant of 105. So just to add one more where you'd have to reciprocate your solution at the end. Okay? Sine of 5 pi over 12. So that is the sine of pi over 6, the cos of pi over 4, add sine pi over 4, cos pi over 6. Same thing, 1/2 root 2 over 2 plus root 2 over 2, root 3 over 2. Okay, talking to the board again, root 2 plus root 6 all over 4. Okay? So those are the softball questions that they put on the start of the second section of the exam, because you should do it enough times that you should be able to get that fairly easily. All right. Solve algebraically. So again, we convert using your identities. Factor it out. And it says for the general solution, so we have to add our 2k pi. So for this one, it's x such that we get 0 at pi over 2 and 3 pi over 2. So I could add pi to it, or k pi, sorry. And if you actually know what's happening here, so that's pi over 2, add a pi, which takes you to 3 pi over 2. That already covers this guy right here, because that happens at 3 pi over 2 anyways. So if you did it a second time, you'd be redundant, but whatever. So that would be at pi over 2, 3 pi over 2 plus 2k pi. So I don't need to do this, the 3 pi over 2 part, because it's already taken care of right here. Because cos x is equal to 0 also when sine x is equal to -1. So that's that. Sine alpha is -4 over 5 in quadrant 3.
Sorry, could you go back a second to that last question?
You bet. Go ahead. You just copying it down?
Either answer.
Pardon me?
So it could have been either answer.
Yeah, unless you added 2 to this, then you'd have to use this and this.
Yes.
Like I had cos x equals 0 and then sine x equals -1. Is it? But then I messed up. X is equal to 3 pi over 2 plus k pi, not 2k pi. So would you take a mark off of that, or?
So you had this one add k pi?
I had plus k pi, not 2k pi.
It would still be it's the same as this. These are exactly the
Yes.
same thing. All right. Well, I shouldn't say they're exactly the same thing. If I take the 2 out of this guy, they are the same thing.
Okay. Sure.
Right? Because they take you back to the same spot every time.
Yeah.
Yeah, see, I put mine with x is equal to pi over 2 plus 2k pi.
Okay. But then you'd have to add it, then you'd have to have the 3 pi over 2 in there as well.
Oh, because when I did it on my, sorry, never mind.
It's all good. Okay. Yeah, like, so your options are this with 2k pi and this with 2k pi. They all work. So it's one of those 3 options. So sorry, I've got to dismiss that. There we go. Okay.
So mine was pi over 2 plus k pi. K is an algebra integers, that's correct.
Yes.
Okay, so that question was right. That's right. Sorry.
That's all good. It's all good. Okay, so now I got quadrant 3. Oh, I think it's alpha, right? So negative 4 over 5, which means this is negative 3. Okay, and it says cos alpha minus pi over 6. So that's cos alpha cos pi over 6 plus sine alpha sine pi over 6. So negative 3 over 5 and root 3 over 2 plus a half and negative 4 over 5. All right. Four over 10. I think that's the answer.
And it's all right. Is it all right if I put negative 4 minus 3 times root 3 over 10?
Yeah, for sure.
That'd be okay.
Just want to make sure. Yeah, I think that's the correct answer. I don't have the answers here. So I'm guessing, I think that's right. Okay? All right, 12, 210 x cos squared x equals 1. So 2 sine x over cos x times cos squared x equals 1. So that cos x and that cancels. Now, the one thing that we have to remember for this is that we have non-permissible values. So cos x can't equal 0. Therefore, x cannot equal k pi, where k is an integer. All right? Is that right? No, it's pi over 2. Okay, so now when I solve this, I have 2 sine x cos x equals 1. Well, that's the same as the sine of 2x equaling 1. Okay? So if I change this to sine theta, where does sine theta equal 1? Well, that's at pi over 2, right?
Yep.
Okay? And then I got to go around the circle one more time because I've got 2 of them. So that now is 5 pi over 2. Okay? But I'm not looking for theta, I'm looking for 2x. So 2x equals pi over 2. 2x equals 5 pi over 2. Therefore, x is equal to pi over 4. And 5 pi over 4. Those are your 2 solutions for that question.
I've gotten everything but like 100% so far.
Okay. All right, last one then. 2 cosquared x, I'm going to change to 2 times 1 minus 2 sine squared x plus 3 sine x minus 3 equals 0. So I get 2 minus 4 sine squared x plus 3 sine x minus 3 equals 0. I'm going to move everything. Well, I'm just going to. So I have that. I don't like the negative in front of the 4. So I'm going to move the negative. So I'm at that point right there. Think, right?
Yeah, and then I factored mine. Like, I got,
Can you factor that though? I don't think you can.
yeah, like, so I pulled up my 2 in the beginning, and it was 2 minus sine x squared plus 3 sine x minus 3 is equal to 0. And then I added my 2 and my negative 3 together, and I got negative 1 minus 2 sine x squared plus 3. Then I pulled out the common thing, so it was negative 2 in the first bracket, and then negative 3, and then you can factor it.
There's an error there.
But then I got my answer to be sine x is equal to 1 squared, and sine is equal to a half.
Yeah, but you can't. See, if you're substituting right off the bat. Oh, here's my error. There's an error here. So just give me a second. There's that, there. There we go. Sorry.
Yeah, and then
My error.
I have the
This
same
is 1 minus
yeah.
sine squared. This is 2 minus 2 sine squared. That's 2. That's 2. Now I can get it to work. Yes. So now I have 2 sine x minus 1 sine x minus 1 equals 0. Sine x is equal to 1/2 and 1. So x is equal to pi over 6, 5 pi over 6 plus 2k pi, where k is an integer, and equals to pi over 2 plus 2k pi, where k is an integer. There's your 3 solutions for that question.
Yeah, I don't know what I did wrong, because I got, like, on my assignment, I got 10% off or 9% off, but I have every single answer that you did when you went over it. Do you want to know what I did?
Dalen, you lost on the sine 2x question. You lost 1/2 on it. Pi over 2 plus k pi. Let me just look back. Okay, there's, yeah, you got it right. I had it marked incorrectly. You had a bit of a mess on the sine part of it, so I have to change that. Mary, go ahead.
I got it right, but I did something a little different for that one.
Okay. You tell me how, you go ahead and tell me how you made out.
Okay, so from the beginning, I went at minus 3 sine x to the other side. And I also I added 2. So that when the left side is that identity 2 cos squared x minus 1. And then
Yep.
that was 1 minus 2 sine squared x is equal to minus 3 sine x plus 2.
Mhm.
And then I just moved it to one side, and then I, what do you call it? Not FOIL, but
Factor?
yeah.
Okay. And it worked out the same way.
Yeah.
Yeah, okay. Perfect. No, I agree. It's all good. There's always more than one way of doing these questions, so that works as well. Okay. Are we all right with that assignment then?
Is that the only thing that I did wrong?
Yeah, that I can see right now. Yeah,
Okay.
I think I added it wrong too. It's probably the other part. Okay. Everybody's all right now with that?
Yep.
Okay. What?
Mr.
Yes, sir.
Do you have my test there? Or
Somewhere. What do you need?
I just wondered, because I think I got a couple marks off too. I couldn't really see what I did wrong.
You had 1 mark off. And
Okay.
it's that same question with Daylin. No, your mark came off on number 12.
Well,
You forgot. Look at your number 12. You were missing.
oh yeah, true. I forgot
This-
5 pi over 2.
You forgot the 5 pi over 4. Yeah.
Okay, that's cool. Yeah.
Okay. Good.
Good.
Okay. Right on. All right. Any questions from chapter 8 then today?
No, I don't have any.
Okay. Mary, how about yourself?
I'm good.
Okay. Brendan?
4293.
Yeah.
8.3 question D, 6D.
Yeah.
When you have like the log, log 7, 100 minus log 7, 25, so that'd be 100 divided by 25 is 4, and then 4 divided by 4 is 1, so you should have log 7, bracket 1, right?
You should have log of 1 to the base 7. Agreed.
Yeah, sorry, log 1 to the base 7.
Yes.
So then your answer would be 0, right? Because
That's-
you're trying to find
Yes.
the exponent of that.
Yes. Yeah. Do you know why that works? Do you know why it's 0?
Well, 1 to the exponent of 0 is 1. Anything to the exponent of 0 is 1, isn't it?
Right. So in that question, you would have ended up with this. So you've got the log of 100, basically divided by 100, right? To the base 7.
Right.
So that's the log of 1 to the base 7, right? If I were to put an x here, right? If I was to put an x there and change it to exponential, I'd get 1 equals 7 to the x. So the only thing that x can be is 0, because that's the only way you can get an exponent in which you're going to get a value that equals 1, right? So that's
That
why.
makes sense.
Okay, and that works every single time. The log of 1 to any base is always going to equal 0. Okay? All right. Anything else on that chapter 8? 9 and 10 are the key components of that one. So you want to make sure you can do questions 9 and 10. Those are the 2 key components of that. All right, so I'm going to, tomorrow, I will go through 9.1. Just, I'll introduce it to you. And then I'm also going to give you an assignment that'll be do middle of next week for chapter 8. It'll be kind of a combination of 7 and 8. It'll be exponential and logarithmic. Okay? All right, so that takes care of pre-calculus today. I'm just going to shut any physics stuff today? Did you guys get a chance to read through that material I assigned yesterday?
Was that material just like on Edmodo? I didn't really get a chance to look at it.
No, it was on. No, I put it on YouTube, but I'll put it on Edmodo right now.
Okay, because yeah, I didn't really see anything there. It's on YouTube. Okay.
Yeah, I put it on the. Okay, so read pages 465 to 476 and complete the questions on the Group A questions. On page 476. And I'm going to attach a video to that too that you can watch that'll give you kind of the most basic information that you need off of that. Okay? So I'll do that in about 10 minutes. I'll put that on Edmodo for you.
And then was there an answer key for that at all, or?
It may have been attached to the last answer key I gave you out of the textbook. You can have a look. If it's not, you can add it. I'm going to go through them with you tomorrow anyways.
Okay.
So I want you to kind of get started on it, and then I'll answer any questions that go with it. Okay? Anything else today, gang? Questions, concerns? So tomorrow, 9.1 pre-calculus. I'll put your assignment on Teams tomorrow, and physics. We'll go through those questions on page 476.
Well, Mr. Hinton, I didn't get a chance to ask you. I wasn't here yesterday. What was the result of that meeting?
Not in our favor right now, to be honest with you.
Oh.
So what's going to happen?